Welcome into the next video in my series on essential skill number 1 for AP Chemistry, dimensional analysis and mole conversions. This video is going to focus on an introduction to stoichiometry, which is mole conversions applied to chemical reactions and to converting between different reactants and products within a chemical reaction. And so to do this, to convert between different substances, you need, first of all, they need to be in the same chemical reaction. You need to have a balanced chemical equation. And then you need to convert from moles of the one substance to moles of the other substance using their coefficients. Okay, so here's an example of a chemical equation, a balanced chemical equation. And really what this equation is saying is that two HCl molecules will react with each other to produce one H2 molecule and one Cl2 molecule. But another way we could interpret it is that it's saying that 2 moles of HCl will react to produce 1 mole of H2 and 1 mole of Cl2. Because a mole is simply a fixed number of molecules. It's 6.022 times 10 to the 23rd molecules, regardless of what substance we're talking about. So the mole to mole ratio is the same as the molecule to molecule ratio or atom to atom ratio, depending on the specific reaction. And so because of this, we would say that 2 moles of HCl, 1 mole of H2, and 1 mole of Cl2 are all stoichiometrically equivalent to one another, at least in this reaction, which basically means that they can be used kind of as a conversion factor in a mole conversion dimensional analysis type problem. So let's look at an actual sample calculation. So how many grams of hydrogen gas are produced when 30 grams of ammonia, NH3, decomposes into hydrogen gas and nitrogen gas? So the first thing we would want to do, first of all, we recognize that this is going to be a stoichiometry problem because we're converting from the amount of one substance, NH3, into the amount of another substance, hydrogen gas. So the first thing we're going to have to do is write out a chemical equation and balance it.
So this is our chemical equation for the decomposition of ammonia into nitrogen gas and hydrogen gas. Remember that nitrogen and hydrogen are diatomic elements, so nitrogen gas is N2 and hydrogen gas is H2. Now we have to make sure our equation is balanced, which it's not right now. So to balance it, we can put a 2 in front of the NH3, gives us 2 nitrogens on both sides, and then a 3 in front of the H2 gives us 6 hydrogens on both sides. So this is our balanced chemical equation for this reaction.
And then we can sort of start our dimensional analysis mole conversions. Okay, remember to apply the coefficients and convert from one substance to the other, we need to be in moles. We need to do moles of one to moles of the other. So in terms of the actual conversion, the first thing you need to do is convert into moles of your starting substance. And I say if necessary because in some cases you may actually just be given the moles to start. But in this case, we're not. We're given the grams of NH3. So we first would need to convert that into moles.
Now they give us the starting grams of NH3. We first have to convert that into moles. Okay, now we've already covered how to do this type of conversion, grams to moles. We're going to put grams on the bottom, moles on top, and then we use the molar mass. The molar mass tells us how many grams are in 1 mole of that substance. If you look at the periodic table, calculate the molar mass of NH3, you get 17.034. Grams of NH3 cancel. Okay.
And then once we're into moles, we can then do the mole to mole step. going from moles of the starting substance to moles of the ending substance, using the coefficients from the balanced equation.
And now that we're into moles, now we can do kind of our new step that's new in this video, which is the mole to mole conversion. Okay. Now, I mean, if we're going mole to mole, we're gonna put mole on top, mole on the bottom. So it's the same unit, so you have to label this carefully. Well, we're going from moles of NH3, so I'm going to put moles of NH3 on the bottom. And then I'm trying to find the amount of H2, hydrogen gas. So I'm going to put moles of H2 on top. So make sure you label not just moles, but what substance you're talking about, otherwise it won't make any sense. And then when we do this conversion, we put just their respective coefficients from the equation. So the coefficient for H2 is a 3, and the coefficient for NH3 in our balanced equation is a 2. And then the moles of NH3 cancel. We get our moles of H2.
And then if it just asked for moles of hydrogen gas, we would be done. But it doesn't. It asks for grams of hydrogen gas, which is very common, or as we'll see in future videos, it could ask for some other unit. And so we'll need to do sort of a final step where we convert out of moles. Again, not always. If it just asks for the moles, we wouldn't need to do this. But oftentimes it will ask for it in a different unit. And so if so, we will need to do kind of this final conversion to convert out of moles.
And then if it was asking for the moles of H2, we'd be done, but it's asking for the grams of H2. So we have one more step to go from moles of H2 to grams of H2. So we'll put moles on the bottom, grams on top. And again, when we're converting between moles and grams, we use the molar mass. Molar mass of H2 is 2.016. That's going to go with the grams. That tells you, molar mass tells you how many grams are in 1 mole. So 2.016 grams are in 1 mole of H2. Moles of H2 cancel. And we can just go ahead and do our calculation. So it's going to be 30 times 3 times 2.016 divided by 17.034 divided by 2. And so you should get, we will keep 3 sig figs here, 5.33. 5.33 grams of H2.